Welcome to today's video on solving exponential and logarithmic equations. So first, a logarithmic equation, if it has logs on both sides, you want to have single logs on both sides, which means you need to condense. So first we're going to roll the 3 halves back, so we get log base A of x equals log base A of 9 to the 3 halves plus log base A of 2. Now the plus means we're going to multiply, so we get log base A of x equals log base A of 9 to the 3 halves. Well, remember that's the square root of 9 to the third, which means it's 3 to the third, which is 27, times 2. So log base A of x equals log base A of 54, so x equals 54. So here, since it's addition, we can condense that into multiplication. So it's 6 times x plus 2 equals 3. However, there's only one log. There's only a log on one side. So this is where you need to translate into an exponential equation. So once again, when we translate, it's the base, so 3. The exponent is also 3, and it's equal to 6x plus 12. 3 to the third is 27. Subtract 12. So 15 equals 6x. And then x equals 15 over 6, or when you reduce, that's 5 halves. Is what x is equal to. Now logarithmic, we've talked about some exponential equations, and I'm going to write it, because we're running out of room, I'm going to write it over here to the side. So the first one that we're going to talk about is 5 to the x equals 32. And previously when we've done these exponential equations, we made them powers of the same base. However, 5 and 32 cannot. So if they cannot be powers of the same base, we're going to take the log of both sides. And the reason that we're going to take the log of both sides is we need a reason to get we need something to get the x out of the exponent. So we're going to go log 5 to the x equals log 32. Because remember, if the exponent is, if the log is raised to a power, that we roll this to the front and make it multiplication. And then to get x by itself, we divide by log 5. So when you do this on your calculator, you're going to go, let's clear it, we're going to go log 32 and then divided by log 5. And it gives you 2.15 approximately. And that is your answer. So for the second one where it says 7e to the x minus 3 equals 49, before we take the log, we need to isolate the base. So that means we're going to divide by 7 to get the e by itself, because e is the base of the exponent. So we're solving e to the x minus 3 equals 7. Because the base is e, we are not going to use log, we're going to use ln in this case, but only when the base is e. The reason why is because when we take the ln of e, remember that'll be 1. So you roll this to the front and you get x minus 3 ln e equals ln 7. Well, the ln of e is equal to 1, so therefore it's just x minus 3 equals ln 7. And then you add 3 to both sides, so you get x equals ln of 7 plus 3. So when you type that in your calculator, you're going to go ln 7, close the parentheses, and then go, I need to move this. There you go. Nope, that didn't work. ln of 7 plus 3. Sorry, some of the buttons that I need to use are hidden behind some buttons for the video. Equals 4.95 approximately. So there you go. All right. So that's solving exponential equations using logarithms and also logarithmic equations. Now, using these for word problems, there's a couple types of word problems that we can use these equations for, and that is one, compound interest. So compound interest is when you put your money in a bank or you borrow money from somebody, that the interest, that basically that money is either accruing interest, money on top of money, or it's compounded a certain amount of times per year, or it's compounded continuously. So the amount of money you put in, the P, is called the principal. The amount of money that you invest, that you end up with is what's the A. So P is the principal. That's your initial investment. A is the ending amount. The R is the interest rate, and that is a decimal. Very important that you change that to a decimal. N is the number of compoundings per year. And T is the time in years. If it's compounded continuously, you don't need the number of compoundings. That's where the 1 plus R over N changes to an E. Because that's what E is as the N gets bigger. So the first problem says how many dollars must be invested at 16% compounded quarterly to yield 10,000 at the end of 5 years. So our A is 10,000. Our P is what we're trying to find. The rate is 0.16 because it's 16%. Compounded quarterly, that's 4 times a year, and 5 years. So when we put that in our equation, it's 10,000 equals P times 1 plus 0.16 over 4 to the 4 times 5 power. So to find P here, since this is multiplication, we just need to divide to the 20th. So we divide. Now, we can put this in our calculator at once. We don't need to split it up. In fact, it's not recommended because that's where mistakes happen. So when we type this in our calculator, you put 10,000 divided by, then you need a parenthesis. So it's 1 plus, sorry, I'm trying to get the plus sign. plus 0.16 divided by 4, and that's raised to the 20th power. And then you hit enter. So that means you had to invest $4,563.87. $1,563.87. That is the principal. That is how much you would have to invest. All right. For the next one, it says how much will a $4,000 investment be worth after 5 years? So the P is 4,000. The A is what you don't know. The time is 5. It's compounded quarterly, so 4 times a year, and the interest rate is 0.08 because it's 8%. So here it's x equals 4,000 times 1 plus 0.08 divided by 4 to the 4 times 5 power, which is 20. So when you type that in your calculator, you can do that all at once. So it's clear. So it's 4,000 times 1 plus 0.08 divided by 4 raised to the 20th power. So it's $5,943.79. And of course, you would write your answer in a sentence. I'm just not for the time. Now for continuously, this is where you do A equals PE to the RT. So there is no compoundings because it's compounded continuously. So the principal is 3,000 here because that's what's invested. The rate is 5%, 0.05. And you're trying to figure out how long it's going to take to double. So the ending amount is 6,000, but time is the x. So 6,000 is equal to 3,000 e to the 0.05x. So remember to solve for this, since it's an exponent, we're going to first divide. So it's 3,000. So that gives us 2 equals e to the 0.05x. And now since the x is in the exponent, we're going to take the ln of both sides. And that's going to allow the 0.05x to roll to the front. And remember, the ln of e is equal to 1. So it's ln 2 is equal to 0.05x. And then you just divide by 0.05. So when you type this in, you get ln 2 divided by that's a negative sign, 0.05 is equal to 13.86, so approximately 13.86 years. So it will take years to double. So almost 14 years to double. All right, there's also exponential growth and decay. And this is where something either grows or decays over time. We're going to talk about population growth. And the A is the same, the ending amount. The A sub 0 is like the P, that's the beginning amount. So that's the beginning amount. The K is like the R, is the rate of growth. And then the T is the time. So here it says in 1990, the population of Africa was 643 million. By 2006, it had grown to 906 million. So our initial amount is 643 million. Our ending amount is 906 million. The time that it took was 16 years. We don't know what the rate is. That's what we're trying to find. So here, to set up to find the rate, we go 906 equals 643 e to the 16x. So then you divide. So 906 divided by 643 is 1.41 approximately. So then remember, you take the ln of both sides to get the exponent out of the variable, or the variable out of the exponent. So then you're going to roll the 16x to the front. And then, so you get ln of 1.41 equals 16x, because ln of e is 1, divided by 16. So if I go ln 41 divided by 16, oh, that's 166. Let's try that again. So you get 0.0214. So that means the rate is approximately 2.14%. So when we write a model, we're going to say that A is equal to 643 e to the 0.0214 t. That is our model. That is the equation that we can use to predict the population for any other time in Africa. So then it says, by which year will it reach 200,000 million? So that means A is going to be 2,000. So when we put in 2,000 for A, we have to solve for T. So we divide by 643. So we take 2,000 divide by 643. So we get 3.11. And then we take the ln of both sides. And we roll this to the front. So we get ln 3.11 equals 0.0214 t ln e. So we divide by 0.0214 to get what t is, because remember ln of e is 1. So ln 3.11 divided by 0.0214 gives you 53.02 years. So it says by which year, if you take 1990 and add 53.02, you get approximately 2043. That is the year. That it'll reach 2,000 million. So the last one talks about the rate of decay. It says radioactive isotope carbon-14 decays at a rate proportional to the amount present. If the decay rate is 12.1%, that means negative 0.121. That's what the R is. And the current mass, or the current mass there, is 135.2. It wants to know what the ending amount will be 2.2 thousand years from now. So basically 2,200 2,200 years. So if you set it up, So saying A equals 135.2 e to the negative 0.121 times 2,200, and just substitute that in your calculator. Second function e, because ln, second function ln gives you e, negative 0.121 times 2,200 and you get 0. That means that it will have decayed to 0. Sorry, the year should be 2.2 because it's per 1,000 years, so the time is just 2.2. So we'll change that in our calculator. So if you want to change something like that, you just hit enter, and then you can scroll. You can easily scroll up, but we'll just retype it. Let's see, clear. There we go. So if you want to, you can normally, we'll just retype it. Here we go. So 135.2, second function e to the negative 1.21 times 2.2. And that gives us 9.44 grams left. All right, that concludes today's video, and I hope you have a good evening.